So in this video, I'm going to prove a series of additive trigonometric identities. So to prove this, I'm going to apply the compound angle formula to these two terms here. So this will become 2 times sine of a half a cos of a half b plus sine of a half b cos of a half a times cos of a half a cos of a half b plus sine of a half a sine of a half b. Now if we expand these two brackets, we get 2 times sine of a half a cos of a half a cos squared a half b plus sine of a half b cos of a half b cos squared a half a, and then we add sine of a half b cos of a half b sine squared a half a, and then our final term is sine of a half a cos of a half a, and then this is multiplied by sine squared a half b. Now this is the same as here we have sine of a half a cos of a half a, and here we also have sine of a half a cos of a half a. So we can factorise these, giving us sine of a half a cos of a half a multiplied by cos squared a half b plus sine squared a half b. And then we see these two terms we can factorise out as sine of a half b cos of a half b multiplied by cos squared half a plus sine squared a half b. Now we know that cos squared x plus sine squared x equals 1, so this will just become a 1, and this will just become, this should be an a, this will just become a 1. And if we also expand the 2 out, we get 2 sine of a half a cos of a half a plus 2 sine of a half b cos of a half b. And now we know that 2 sine x cos x is just the same as sine of 2x. So using this double angle formulae, we get sine of a plus sine of b. And so we proved our original conjecture. So now, to find what sine of a minus sine of b is, now we know this is the same as sine of a plus sine of minus b, because sine of minus b is just the same as minus sine of b. Now if we plug this into here, we're going to get 2 sine of a half a plus minus b, which is just minus b, because of a half times a minus minus b, which is just plus b. And so this is our formula for sine a minus sine b. So to prove this, we're going to apply the compound angle formulae on these two terms. So that will give us 2 times cos of a half a cos of a half b minus sine of a half a sine of a half b, and then multiplied by cos of a half a cos of a half b plus sine of a half a sine of a half b. Now we can see that this is just the difference of two squares, and so we're going to get cos squared a half a cos squared a half b minus sine squared a half a sine squared a half b. And now from here we can apply the double angle formulae to these coses and these sines. So first of all, we know that cos of x equals 2 cos squared x over 2 minus 1, which means if we rearrange this, we get cos squared x over 2 equals cos x plus 1 over 2. And we also know that cos of x equals 1 minus 2 sine squared x over 2. And so rearranging, we get that sine squared x over 2 equals 1 minus cos x over 2. So if we now plug this in for all of these, we're going to get 2 times cos of a plus 1 over 2 times cos of b plus 1 over 2 minus 1 minus cos of a over 2 times 1 minus cos of b over 2. So from here, if we now expand these inner brackets, we're going to get cos of a cos of b plus cos a plus cos b plus 1 over 4 minus, this will be 1 minus cos a minus cos b plus cos a cos b over 4. Now, because the denominators are the same, we can now just cancel out some terms. So we're going to have a plus 1 and a minus 1, and we also have a plus cos a cos b. So to prove this, we're going to apply the compound angle formula on these two terms, giving us minus 2 sine of a half a cos of a half b plus sine of a half b cos of a half a times sine of a half a cos of a half b minus sine of a half b cos of a half a. And here we see that this is just the difference of two squares. And so this is minus 2 times sine squared of a half a cos squared of a half b minus sine squared of a half b cos squared of a half a. And now from here we know that cos of x equals 2 cos squared x over 2 minus 1. And so rearranging gives cos x plus 1 over 2 equals cos squared x over 2. And we also know that cos of x equals 1 minus 2 sine squared x over 2. Rearranging gives us sine squared x over 2 equals 1 minus cos x all over 2. So substituting that in here gives us minus 2 times, so this first term will be 1 minus cos a over 2, and then multiplied by cos b plus 1 over 2, minus 1 minus cos b over 2 times cos a plus 1 over 2. So expanding these two inner brackets gives minus 2 times cos b minus cos a plus 1 minus cos a cos b over 4 minus cos a plus 1 minus cos b minus cos a cos b over 4. And now this becomes, so because the denominators are the same, we can just treat that as a common denominator, and then we expand this negative, and we see that we have a minus cos a cos b minus minus cos a cos b, which will cancel out, and we also have a 1 minus 1 here. When we have cos b minus minus cos b, we're going to get 2 cos b, and we have minus cos a is minus 2 cos a, and so this is all over 4. Now if we multiply this negative in, and we also times this inner fraction by 2 and then divide by 4, this will just give us cos a minus cos b. And so we prove that. So to prove this identity, we're going to write tan of a as sine a over cos a, and tan of b as sine b over cos b. Sorry, this should be over cos of a. And now we combine the fractions together to give us sine a cos b plus sine b cos a over cos a cos b. And we see that this is just the compound angle formulae for sine of a plus b. And so this just becomes sine of a plus b over cos a cos b. And so we prove that. Now we're also going to find what tan of a minus tan of b is. And so we know that tan of minus b is the same as minus tan of b. And so this is the same as tan of a plus tan of negative b. And now if we just plug this into that formula, we get sine of a minus b over cos of a times cos of minus b. Now we know that cos of minus b is just cos of b, and so this becomes sine of a minus b over cos a cos b. And then we're done. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.